In today's video, I'm going to walk you through the full process of creating your own custom PCB using KiCad, from the initial idea all the way to the production files. Before even opening KiCad, you need to know what you're building. A PCB is just copper traces and connections. This means that you can design anything, but only if you understand your circuit first. For this video, I'll go through a practical example. I'm going to design a dev board for an ESP module. That means before going into KiCad, there are a couple of things that you should check out. The first one is the datasheet of the module that we are going to use. We're going to use this one right here, the room with the built-in antenna, and also I strongly recommend finding some application notes online. In this case, we are lucky because Espressif has its own dev kit around this kind of module. We can find the schematic, the PCB layout, and also other related documents from the Espressif website. This is the kind of things that you should always check out before designing your own PCB. Right here, as you can see, we are in the KiCad software. The first thing that you want to do is to create your own new project, and then we can start. The first thing is to enter the schematic editor. This is where you define how everything is connected. Each component is represented by a symbol. Right here we got the standard symbols. This one is, for example, the symbol for our ESP module. And basically now we are creating the logic of your PCB. This step is just as important as creating your own PCB layout. But now let's see how we can use the symbols to create our own PCB. If we go back, we can see that in the application note we got different things. We got the ESP32C3 room, then we got, for example, the USB UART bridge, an LDO for the voltage. If we want to recreate this thing on KiCad, we have to add a symbol for every part of this. So for example, if we want to add a button, we can go on the schematic that we have made, and we can, for example, add a switch. We can add a simple push button right here that we can use for the boot button or for the reset button. You also have to add resistors and capacitors. And basically you have to add a symbol for every part of your project, even if it is an IC, a push button, a passive components, or for example test points for debugging your PCB, or for example a mounting hole. These are all the kind of symbols that you want to add in your PCB schematic before going into the PCB layout. Before moving on, I would like to show you my previous schematic for an ESP32C3 room module. This is my previous schematic for a project that I also shared here on YouTube, so check out the video if you want. I didn't want to create a dev kit like this one right here that has all these kind of things, but I prefer to do something easier. And as you can see, I added all these symbols. For example, this one is the pin header, this is the ESP, these are all the capacitors, this is the push button, this is a label, this wire is going to be connected to this one right here. But before moving on, I would like to also say something more. This LDO right here that converts 5 volts into 3.3 volts. We got this name right here. Let's search for this name in the KiCad symbols. As you can see, we don't have anything. This means that if you cannot find the symbol that you would like to use, you can switch to another IC that has the symbol on KiCad. You could create your own symbol, or you should check out maybe DigiKey, TMA, other suppliers that have files of the symbols, the footprint of the IC that they are selling, so that you can download that file and you can add that into your schematic. After your schematic is ready and everything makes sense, you can move on with the PCB design. In my opinion, you should move on with the PCB layout even if you're not 100% sure on the schematic, because at the end you're going to check everything and you can always move back and adjust something. The first thing that you need to do is to assign a footprint to each symbols. For example, right here in my previous project, I decided to use 0805 packages for the passive components. If we go here, we can see that the footprints is this one. A footprint represents the physical shape of the components that you would like to use. For the SMD components are the pads, and for the through-hole components are the pins. For example, capacitor. For the through-hole, as you can see, we got this holes right here. As I said before, you can create your own symbols and you can create your own footprints. But it's a feature that you're not going to use a lot. Instead, you could use a standard footprint and you can decide to change something in that footprint. Right here is actually smaller than this one. This is because I decided to change it. This is a thing that you should know, because sometimes you just want to assign a specific pin on the symbol to pins and pads. For example, as I said before, I can do edit footprints, and as you can see, I decided to move these lines to avoid problems on the DRC. After you have assigned to all the symbols related footprints, you can start creating your own PCB layout. For example, right here you can see what it looks like when you convert all the schematic into the PCB layout. You have to connect all these kind of pads through hole pins with the schematic that you have created. I'm not going to explain how, because it really depends on your project, on your kind of PCB that you would like to do. But once the schematic look clean in your opinion, it's time to check for all the errors, because once you get your own PCB, it's really annoying to go back, change something and reorder that PCB. It takes a lot of times, so it's better to check for all the errors beforehand. In this case, after I created this PCB layout, I sent this board on Reddit to get a review, so I recommend that you could do this as well if you don't have anyone to send your PCB layout for a review. If you're starting out, I recommend to just go and design some easy schematics, some easy boards like 5 timers, things like this, to just get started and create your own PCB. It's basically trial and error, so the more you do, the more you learn, and you can use the DRC for finding your errors. After this point here, where you have checked all the errors, you now have to check if the components are available for your design, and also you have to generate all the production files if you want to purchase your board. Right here you can see fabrication outputs, and you can see the Gerbers of the files and the drill files. These two are necessary, but if you want also the assembly service, you also have to send other files like the bills of materials, the component placements. Thank you for watching. Of course, this video is just about the workflow of KiCad, and it's not a step-by-step tutorial on how to use KiCad, but the best way is to learn by doing. But thank you for watching, and we're going to see in the next one with new projects, new ideas, and also new videos.